Okay, so in this video, we're going to finish off the playlist by doing some exam style questions. And let's just go, let's get started. So it says here that at a restaurant, there are 4 starters, 11 main courses, and some desserts on the menu. It doesn't tell us how many desserts there are on the menu. Alice is going to select 1 starter, 1 main, and 1 dessert, and correctly calculates that this can be done in 308 different ways. Tim is only going to order a main course and a dessert. In how many different ways can Tim choose his order? So I think the thing that we've got here is because we've got 4 starters and we've got 11 main courses, but we don't know how many desserts there are. In fact, I might say that the number of desserts that are on the menu, I could just give that a different letter. I could call it Y, I could call it X, whatever I want to do. I know that when I multiply those 3 things together, this is going to give me 308. So all I need to do is if I can find out what Y is equal to, I can then deal with what Tim has going on here, because he's only going to want to use a main course and a dessert for his order. Now, if you were doing this without a calculator, I wouldn't do 4 times 11 and then do 308 divided by that. I'd probably divide by the 4 and then divide by the 11. So I'm going to start off by dividing both sides by 4. So I'd have 11y equals, I'll do the 308 divided by 4. 4 goes into 37 times remainder 2, 77. And then I can divide both sides by 11 so that that's 7. So this means that there are 7 desserts on the menu. It didn't ask for us to find the number of desserts, but it was pretty much the only thing we could do in this question. So that was for Alice. And then for Tim that we've got here, he's going to do a main course, which is 11. And he's going to do a dessert, which is 7. So the number of choices that he's got is going to be 77 different choices. In fact, we could have seen that here because we knew that 11 times by the number of desserts was 77. We didn't even really need to say that Y was 7 desserts, but I think it just makes it a little bit easier to see that one there. So if you were thinking about what kind of question this is like a type 1 question where there are no restrictions at all. Okay, let's have a look at type 2. It says, not type 2, question 2. When buying a new bicycle, Alan is offered some customization options for the frame, handles, and wheels. He can choose from 21 different frame colours, 12 different handle types. It doesn't say anything about the wheels though. It says, Alan says there are a total of 2,532 ways of customizing the bicycle. Could he be correct? So they haven't told us anything about the wheels customization, so I think we might need to find out what that could be. So again, I think this is kind of like a type 1 sort of question because you can pick any of these and they're not going to interact with each other. There's no like, you can't have them the same customizations because they're all different things. So Alan thinks that 21 multiplied by 12 multiplied by the number of things of wheels, let's just say wheels, again, I'm going to use the letter Y for it. He thinks that it could be 2,532. Okay, well, let's start off by dividing by 21, okay? I'm going to get rid of this 21 by dividing by 21. So we think that 12y is going to be 2,532 divided by 21. Let's see if we can actually come up with an answer. So 21 goes into 25, it goes in there once with 4 left over. And 21 goes into 43 twice, because 2 times 21 is 42, with 1 left over. And 21 does not go into 12. So we're going to go to something that has a non-integer that we've got here. And I can just show you that, because if I do 2,532 divided by 21, I get something that is not an integer. So I'm going to just say that we get our, goes in 0 times, and then there is a remainder of 12. So, i.e., it is not an integer, it's going to be 120, remainder 12. You don't actually need to calculate it. So, because this isn't an integer, y will not be an integer. So Alan is not correct. The reason it has to be an integer is because we need to say that there is a whole number of ways that you can customize a wheel. It wouldn't make sense to say, I mean, if I actually find out what y is equal to, if I do 2,532 divided by 21 and then divide it by 12, it doesn't make sense to say that there are 10.047619 ways of customizing a wheel. So it has to be an integer. Now you might have done the division the other way around. You might have done 2,532 divided by 12. That's an integer, but when you divide that by 21, you don't get the integer that you need. So because this is not an integer, y will not be an integer, so Alan is not correct. So it's not possible to have 2,532 ways of customizing it. Okay, our last one that we've got here, it says, at a juice bar, there are 15 different fruits to choose from. Celia is either going to have a juice made from 1, 2, or 3 different kinds of fruit. Show that there are a total of 2,955 different combinations. So if she was just going to pick one kind of fruit, there are going to be 15 different ways that she's going to do that. If there are 2 fruits, this is where we need to think, is it like a type 1, is it like a type 2, is it a type 3? I think it's going to be like a type 2 question because we don't want her to pick the same fruit twice because that's the same thing as just picking one fruit. She's not going to pick apple, she's not going to go up to the bar and say, oh, I'd like an apple and apple juice. It just doesn't make any sense. So she has a choice of 15 fruits for the first part and then only 14 fruits for the second fruit to add in. And then if we are going to be doing 3 fruits, she has 15 ways of choosing the first, 14 ways of choosing the second, and 13 ways of choosing the third. So the total of these combinations is going to be when we add these up together. So it's going to be 15 plus, let's work out the 15 times 14, that's 210. And then we'll do the 15 times 14 times 13, which is 2,730. So all I need to do is just check that we're going to get the 2955. So that's 15 plus 210 plus 2,730, and you do get 2,955 different combinations. Okay, so I haven't done an example that had a type 3 for these exam questions, but we did do some type 3 ones over here, and we also did a type 3 one over here. This is kind of the way they would be asked in an exam. So that's that whole topic of the product rule for counting. If I were you, I would just make sure that you refreshed your mind on this summary page, kind of just before you went into the exam, and just make sure you can tell the difference between these 3 different ways. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. This is the end of the playlist, but head to my channel's homepage to see what else I might be able to help you with. And as always, wishing you the very best for all your studies.